Today, we're diving into one of the most critical, yet often overlooked, problems in all of AI. It's a silent saboteur that can make even the most powerful models completely worthless in the real world. We're talking about something called data leakage.
So you ever wonder about this? I mean, we see these headlines all the time, right? Amazing AI breakthroughs that promise to predict diseases or forecast the stock market with, just incredible accuracy. But then, when they're put to the test, they just fall flat. So what is going on here?
It really is a strange paradox. In the lab, a model might look like an absolute genius, getting a perfect score on every test you throw at it. But the second it goes into production, its performance just nosedives. And this isn't just some small bug, it's a huge roadblock for the entire field. And it points to a very specific culprit. All right, so it's time to meet that culprit. It's this hidden flaw that works in the shadows of the data, quietly corrupting models from the inside out before they ever see the light of day. Let's unmask it. And here it is, data leakage. So what is it? Put simply, it's when your model accidentally gets a peek at the answers while it's still studying. It learns from information that, in a real-world scenario, it just wouldn't have. It's cheating without even meaning to. This is honestly the best way to think about it. Imagine a student, that's our AI model, who gets their hands on the answer key before a huge test. Of course they're going to get a perfect score. But did they actually learn anything? No way. They just memorized the answers. So when the real exam comes, with questions they've never seen before, they're totally lost. And this definition from IBM really hits the nail on the head. The most important words there are inaccurate results. A model with a data leak isn't just a little bit off, it's fundamentally broken. It gives you predictions that are not only wrong, but they come with this false sense of confidence. And that can be incredibly dangerous and costly. So how does this actually happen? How does the answer key, so to speak, slip into the training data? Well, it usually comes down to a few really common and sometimes surprisingly simple mistakes in how we handle our data. Let's break them down. What's so wild is that these leaks often happen during steps that seem totally normal. So take scaling before splitting. This is when you, say, normalize all your data at once. But if you do that, information about the range of your test set has now contaminated your training set, giving the model an unfair sneak peek. And then there's inclusion of proxy features. Ooh, this one is really sneaky. It means you're using a piece of data that is basically a stand-in for the answer itself. Let's look at a couple of examples.
Okay, imagine you're building an AI to predict if a patient has a specific disease. Now, if you include information about the exact medication they were prescribed, your model will look like a genius. But wait, a patient only gets that medication after they've been diagnosed. That information wouldn't be around when you're trying to make the initial prediction. The model has cheated by looking into the future.
Here's another classic. Let's say you want to predict which customers are about to cancel their subscription or churn. If your model includes data on, say, the number of support tickets a customer filed after they canceled their account, well, that's a leak. That data is a result of the churn. It's not a predictor of it. The model isn't learning to predict the future, it's just gotten really good at spotting something that already happened. Now, these might sound like nerdy, technical little mistakes, but the real-world consequences are anything but small. We're not just talking about bad code here. We're talking about bad outcomes that affect businesses, scientific discovery, and even people's lives. The fallout from data leakage is like a domino effect. It all starts with you thinking your model is amazing, this wildly overestimated performance. But then it inevitably fails when it sees new data. And that can lead to some seriously misguided and expensive business decisions. In the world of science, though, the effect is even worse. 294. A huge study in 2023 found that's the minimum number of published scientific papers across 17 different fields that were very likely flawed because of data leakage. And that's a huge deal. It fuels what scientists call the reproducibility crisis. It means other researchers try to recreate the incredible results from a study and they just can't. Why? Because the original results were a mirage, an illusion created by a data leak.
It seriously undermines our trust in science itself.
This chart right here shows you just how massive the drop-off can be. It's from a model that was trying to predict civil wars. So on the left, you see the perceived power of the complex model. The bar is high, looks pretty impressive, but that was with a data leak. Once the researchers fixed it, look at the bar on the right. That's the actual performance. The advantage almost completely vanished. The supposedly brilliant model was barely better than a simple coin flip. All of that intelligence was just an illusion. Okay, so this is obviously a massive problem. But here's the good news. It is 100% preventable. We can absolutely build better, more robust, more trustworthy AI. It all comes down to following a clear set of rules for what we call data hygiene. This is basically the playbook for building leak-proof models. And the golden rule, the absolute #1 thing to remember, is step 1, split first. You have to take your test data and lock it away in a vault before you do anything else. All the other steps really follow from that same principle. You have to treat your test data like it's from the future and you haven't seen it yet. Process your data in careful batches, be ruthless about kicking out any feature that gives away the answer, and try to automate the whole workflow so you can't make these mistakes by accident. So really, the crucial point here is this. Thinking about data leakage isn't some advanced extra credit task for data scientists. No, it is the absolute foundation of building any machine learning model that you actually want to work in the real world. Good data hygiene is everything. And that leaves us with this final, really important question. The next time you see a headline about some new AI model with near-perfect, mind-blowing results, you can now ask yourself, is it a real breakthrough or is it just a leak? Knowing the difference makes you a much smarter observer of this whole AI revolution. Thanks for joining us.